Ever wondered how Chips Ahoy cookies are made? These classic cookies have been a favorite for decades, enjoyed in households across the globe for their perfect balance of sweetness, crunch, and those irresistible chocolate chips. From grabbing a quick snack to sharing with family and friends, they have become a staple in many cultures. But behind the delicious flavor and delightful texture lies a fascinating production process. Today, we are going to take you through every step of how these cookies are made, starting from sourcing the best ingredients to packaging them up and sending them to stores worldwide. The journey begins with the careful sourcing of high-quality raw materials. The key ingredients for these cookies include flour, sugar, butter, or sometimes vegetable oil, eggs, baking soda, and of course chocolate chips. Each of these ingredients plays an important role in the flavor, texture, and overall quality of the cookies, so the manufacturers take great care in selecting the best suppliers for each component. The flour, for example, is made from wheat grown on large farms, as it affects how the dough will behave during baking. The wheat is harvested, cleaned, and milled into fine flour that is perfect for baking cookies that are soft in the middle yet firm around the edges. This flour is inspected at every stage to ensure it is free from impurities like stones or foreign particles. Sugar, a key ingredient that provides both sweetness and texture, is sourced from sugarcane or sugar beets, depending on the region. White granulated sugar gives the cookies their sweet flavor, while brown sugar adds moisture and helps the cookies achieve a soft, chewy texture. Brown sugar also contributes to the deep golden color of the baked cookies. Both sugars are refined and processed to remove any impurities, and each batch is tested to ensure it meets strict quality standards before being sent to the factory. Butter or vegetable oil is used to add richness and flavor to the dough. The butter comes from dairy farms that follow strict guidelines for animal welfare and food safety, ensuring the best possible product for cookie production. Butter is preferred for its rich taste, but in some factories, vegetable oil is used to increase the shelf life of the cookies while still maintaining a great taste. The butter is delivered to the factory in large blocks, where it is softened and measured before being added to the dough. Eggs, another key ingredient, are sourced from carefully selected farms. These eggs go through a pasteurization process to eliminate any harmful bacteria, ensuring that they are safe to use in large-scale production. They help bind the dough together and contribute to the soft texture of the finished cookies. Each batch of eggs is tested for freshness before being incorporated into the dough. Finally, we have the star of the show, chocolate chips. These chocolate chips are made from high-quality cocoa beans that are sourced from tropical regions like West Africa and South America. The cocoa beans are harvested, fermented, roasted, and processed into chocolate, which is then shaped into the small, bite-sized chips we all know and love. The size and quality of the chocolate chips are crucial, as they must hold their shape during baking while still melting slightly to create a gooey texture. The chips are inspected to ensure they meet the right specifications for size and shape before they are added to the dough. It's time for the primary processing stage, mixing the dough. In a large-scale factory, this is done in huge industrial mixers that can handle hundreds of kilograms of dough at once. The process starts with creaming the butter or vegetable oil and sugar together until the mixture becomes light and fluffy. This step is crucial because it helps incorporate air into the dough, which contributes to the cookie's light texture. The eggs are then added one at a time, allowing them to blend smoothly with the creamed butter and sugar mixture. After the wet ingredients are thoroughly combined, the flour and baking soda are added to the mixture. Baking soda is the leavening agent that helps the cookies rise as they bake. The flour is added slowly to avoid overmixing, which could make the cookies tough. At this stage, the dough is mixed until just combined, ensuring that it retains the right consistency for baking. Finally, the chocolate chips are folded into the dough. This step is done carefully to make sure the chips are evenly distributed throughout the dough without breaking or melting prematurely. If you're enjoying this video, make sure to subscribe so you don't miss out on our upcoming videos. With the dough prepared, the next step is to shape the cookies. In a factory setting, this is done using advanced machines designed to portion the dough into perfectly sized pieces. These machines can produce thousands of cookies per hour, each one uniform in size and shape. The dough is dropped onto large baking trays, with enough space between each cookie to allow for spreading during baking. Consistency and size is essential to ensure that every cookie bakes evenly and achieves the perfect texture. Once the cookies are shaped, they are ready for baking. The cookies are placed on conveyor belts that lead them into large industrial ovens. These ovens are capable of baking thousands of cookies simultaneously, maintaining a constant temperature and even heat distribution throughout. The cookies are baked at a temperature of around 175 degrees Celsius for about 10 to 12 minutes, depending on the size of the cookies and the desired texture. During baking, the edges of the cookies become crispy, while the center remains soft and chewy. The chocolate chips melt slightly, creating pockets of gooey chocolate within the cookies. The precise control of the baking temperature and time is critical to achieving that perfect balance of textures. After baking, the cookies are removed from the ovens and allowed to cool. Cooling is an important step because it helps the cookies firm up before they are packaged. If the cookies are packaged while still warm, they could become soggy or lose their shape. The cookies are placed on cooling racks, where they are exposed to circulating air to cool them down quickly and evenly. Once the cookies have cooled, they go through a secondary processing stage where they are inspected for quality. Any cookies that are overbaked, misshapen, or broken are removed from the production line. Some factories use automated quality control systems that scan each cookie for defects, while others rely on human inspectors to check the cookies by hand. Only the best-looking and perfectly baked cookies make it through to the packaging stage. Packaging is a vital part of the process, as it helps preserve the freshness and quality of the cookies until they reach consumers. In a factory setting, packaging is done using highly efficient machines that can package thousands of cookies per hour. The cookies are placed into trays or sleeves, depending on the product, and then sealed in airtight packaging to keep them fresh. The packaging is designed to protect the cookies from damage during transport and storage, ensuring they arrive at the store in perfect condition. Once packaged, the cookies are stored in a temperature-controlled environment until they are ready to be shipped. Depending on the destination, the cookies may be kept in refrigerated storage to maintain their freshness. From the factory, the cookies are transported to distribution centers, where they are sorted and shipped to retailers around the world. Whether they are traveling to a nearby grocery store or being exported to another country, careful attention is paid to ensure that the cookies are transported in a way that keeps them fresh and intact. Trucks equipped with climate control are often used to prevent the cookies from being exposed to extreme temperatures during transit. Sugar is one of the most widely used ingredients in the world, but its journey from sugarcane to the sweet crystals we know is a fascinating and complex process. Sugarcane, a tall tropical grass, is grown predominantly in warm, sunny regions such as Brazil, India, Thailand, and China, which are some of the largest producers. The crop thrives in these hot climates with plenty of water, and once the sugarcane reaches maturity, usually after about a year, it's ready to be harvested. In earlier times, this harvesting was done manually, but nowadays, large machines efficiently cut down the cane stalks, removing the leaves and leaving behind the valuable parts that will eventually become sugar. Once the cane is harvested, the stalks are transported to nearby processing plants, where the first step in extracting sugar begins. The sugarcane stalks are fed through enormous rollers that crush them to release the juice held within. This process of crushing is essential as it extracts the sweet liquid from the fibrous cane. The crushed cane, now known as bagasse, is separated from the juice. Interestingly, the bagasse doesn't go to waste. It's often used as a renewable energy source to power the sugar mills, a clever way to make the process more sustainable. The extracted juice from the cane is then filtered to remove any impurities such as bits of cane or dirt. After filtration, the juice undergoes a clarification process where lime is added to it. This step helps separate non-sugar components from the juice and makes the liquid clearer. Next, the clarified juice is heated in large evaporators to remove the excess water. As the water evaporates, the juice becomes more concentrated, turning into a thick syrup. This is where the sugar starts to take shape. But the process is far from over. The thick syrup is transferred to large vessels known as vacuum pans. Here, the syrup is boiled under reduced pressure, encouraging the sugar to crystallize. Sugar crystals begin to form. These crystals are separated from the remaining liquid, called molasses, using a machine called a centrifuge. This machine spins rapidly, flinging the molasses away from the sugar crystals, leaving behind raw sugar. At this point, the sugar isn't the bright white color we're familiar with. It's a more brownish, raw form. Some of this raw sugar is further processed and refined to create the white granulated sugar commonly used in households and food production. To achieve this, the raw sugar is dissolved, filtered, and then recrystallized to produce the final refined product. The sugar is then dried to remove any remaining moisture and is packed into bags or other containers, ready for distribution. From the factory, the sugar is transported to various markets, both locally and internationally, ensuring that it reaches homes, restaurants, and food manufacturers worldwide. From the cane fields of tropical regions to the sugar bowls on our tables, eggs are a staple ingredient in countless food products. And on a mass scale, cracking and separating them is an incredibly efficient process. In large factories, specialized machines handle thousands of eggs per hour, ensuring both speed and precision. These machines take whole eggs and crack them open with mechanical arms or blades, applying just enough force to break the shell without damaging the egg contents. Once cracked, the egg passes through a separator that quickly divides the yolk from the egg white. The whites and yolks are then collected separately, often to be used in different products such as baked goods, mayonnaise, or protein supplements. The precision of these machines is remarkable, ensuring minimal waste and allowing for the processing of millions of eggs each day. Behind the scenes of this mass-scale egg processing are the large-scale hen farms that supply the eggs. These farms are highly mechanized to handle the volume needed for such operations. Hens are typically housed in controlled environments where temperature, light, and ventilation are managed to optimize egg production. On these farms, hens are fed a carefully formulated diet designed to ensure they lay high-quality eggs. The feed generally consists of grains like corn, wheat, and soybean meal, fortified with vitamins and minerals. This precise feeding helps the hens maintain their health and consistently produce eggs with strong shells and nutrient-rich yolks. The scale of these operations is vast. Hen farms can house hundreds of thousands of birds, each laying an egg almost daily. Automated systems collect the eggs, transport them through cleaning and grading processes, and finally, they are either sent to markets as whole eggs or to factories for cracking and further processing. Efficiency and consistency are key, as the demand for eggs in the food industry is immense, requiring every step from the farm to the factory to be tightly controlled and streamlined. From the hens on the farm to the cracking machines in factories, egg production is an impressive display of modern technology, meeting the enormous global demand for this versatile food staple. Vegetable oil is a widely used ingredient in cooking, baking, and food production, but producing it on a mass scale involves a highly refined process. The journey begins with crops like soybeans, sunflower seeds, canola, or corn, which are grown specifically for their oil content. These plants are cultivated on vast farms, often using modern agricultural techniques to maximize yield. Once harvested, the seeds or kernels are transported to oil extraction facilities. The process starts with cleaning and drying the seeds to remove any impurities, dirt, or moisture that could affect the quality of the oil. After that, the seeds are cracked and pressed using large mechanical presses or expellers. This pressing extracts the initial crude oil, though the yield from this step alone is often not enough. Therefore, many facilities follow up with a process called solvent extraction, where a solvent like hexane is used to dissolve and extract more oil from the remaining seed material. This ensures that the maximum amount of oil is obtained from every seed, making the process as efficient as possible. Once the oil is extracted, it goes through several stages of refining to ensure it's suitable for consumption. The first step is degumming, where water or acid is used to remove any gum or phospholipid content in the crude oil. Next comes neutralization, where an alkali is added to remove free fatty acids, which can cause the oil to go rancid. Then, the oil is bleached, not in the sense of using bleach, but by filtering it through clay to remove any unwanted pigments or contaminants. Finally, the oil is deodorized by heating it under a vacuum to remove any odors or volatile compounds, resulting in a clean, neutral flavor. After refining, the oil is filtered and bottled or packaged for distribution. Vegetable oil produced on this scale is essential for industries that need large quantities of oil for frying, baking, and other food production processes. From the vast farms growing oil-rich seeds to the high-tech refineries that process it, the production of vegetable oil is a testament to the efficiency of modern food manufacturing systems. Cocoa beans, the foundation of chocolate, undergo a fascinating transformation from raw seed to a key ingredient in countless products. This process begins on large-scale cocoa plantations in tropical regions like West Africa, Central and South America, and parts of Asia, where the climate is ideal for growing cocoa trees. These trees produce pods that contain cocoa beans, and when the pods are ripe, they are harvested by hand. Each pod contains 20 to 50 beans surrounded by a sweet, sticky pulp. Once the pods are harvested, they are cut open, and the beans and pulp are scooped out and left to ferment. Fermentation is crucial in developing the beans' flavor and can last from 5 to 7 days. During fermentation, the pulp breaks down, and the beans take on the rich flavor characteristics that will later make them ideal for chocolate production. After fermentation, the beans are spread out to dry under the sun, which can take about a week. This drying step is essential to reduce moisture content and prepare the beans for storage and transport. Next, the dried beans are shipped to processing plants, where the large-scale transformation into cocoa products begins. The beans are cleaned to remove any debris, then roasted to bring out the deep, rich flavors. After roasting, the beans are cracked and their outer shells are removed, leaving behind the inner nibs, which contain the cocoa solids and cocoa butter. These nibs are ground into a thick, paste-like substance called cocoa mass or chocolate liquor. This is the foundation of all chocolate products. The cocoa mass can be further processed in different ways depending on the final product. To make cocoa powder, for example, the mass is pressed to extract much of the cocoa butter, leaving a dry, crumbly substance that is ground into powder. Alternatively, to make chocolate, the cocoa mass is combined with additional cocoa butter and other ingredients like sugar and milk before being refined and conched, a process where the mixture is continuously mixed and aerated to improve its texture and flavor. From the tropical cocoa farms to the state-of-the-art processing plants, turning cocoa beans into chocolate and other products is a complex and fascinating journey that depends on both traditional practices and modern technology.